ZARM Institute, University of Bremen, so in Germany. And today I'm going to introduce you some of the projects we are doing in the University of Bremen to prepare a sustainable human presence on Mars. So, just for a bit of context about Bremen, maybe I think a lot of you already know Bremen. It's one of the major European space hubs. We are talking about more than 140 aerospace company or organization and more than 20 research institutes across the city. So just as a few examples, I've put the logo of some of them, the last one being ZARM, so where I'm working. But it's also a big community for the public because every year we are hosting very popular event. For example, the Space Tech Expo that happened I think it was last week or some days ago, where I already met some of you. And this week, of course, the Ministerial Council of ESA, which was a great success, so we are quite happy. But never mind, it was just for the context. We are here today to speak about Mars. An extremely constrained environment, as everyone perfectly described today. Almost no resources, harsh conditions, and zero margin for error when we send humans on Mars. It's potentially habitable but very hostile. So preparing for human exploration on this planet means understanding perfectly this constraint and know how to work with them and not against them. And this is exactly what we are doing in the University of Bremen via the first project I will introduce, the Human on Mars initiative. So it's just some picture of the researcher involved. This project, you have a QR code if you want more information, but also I will have time today and tomorrow. So Human on Mars was the first large-scale initiative of the University of Bremen dedicated to preparing a sustainable response and responsible human presence on Mars. It was created to explore what it would realistically take for humans to go live and work on Mars. It brought together researchers from multiple disciplines: robotics, microbiology, engineer, space, engineer, everything. You can imagine also psychology. It was funded by the state of Bremen for 3 years and it's ending last month. We had great results and all of this project was aimed to work on the 3 main research stems. So first, the human factor and the interaction between human, robots, and how they work together. Also, the habitat and life support system, the autonomy, resilience, and sustainability. And the in-situ resource utilization of materials that Mars can offer. Concretely, it was 8 seed projects, everyone led by 1 professor and 1 research group at the University of Bremen. I will not go through all of them, don't worry, but I would like to highlight one of them, the living habitat. So the goal of the living habitat was not to put human inside in a closed environment and study the psychology after some weeks or months or whatever. Here, the human was just staying for like work hours, and the goal was really to understand, okay, in a replica of a mini laboratory in this Moon and Mars base analog, how they can work and how we can integrate system inside this laboratory, for example, life support system, and more essentially, if there is a failure in the system, how do they deal with that with just what they have around? Because this is what will happen on Mars. If you have a failure, you will have to deal with it only with what you have around you. This is just another view, a schematic view, because it was also aimed to have multiple modules link the one with the other. This facility was designed and built in ZARM, so where I'm working, and we are very proud to have this. So all of this work and all of the work from the other 7 seed projects, they have laid the foundation for a much bigger project, the Cluster of Excellence, the Martian Mindset, that will start in January and be funded for 7 years. So what is the Martian Mindset? That's an important question. It's a large-scale research program funded by the DFG, so the German Research Foundation. Its goal is to develop a completely new way of designing production on Mars via only the resources that you can find on site. This cluster brings together a lot of researchers, again from fields like robotics, microbiology, psychology, engineer. It's one of the most highest and most competitive research programs of Germany, so we were very happy and proud to be awarded from the DFG. It represents more than 50 million euros of funding for 7 years. It brings together 20 research groups and has opened 40 fully funded PhD positions. It also positioned the University of Bremen to acquire the title of University of Excellence in Germany, which is, I mean, as you can guess, a very prestigious title. And all of these researchers are working together to answer one fundamental question: how do we produce everything we need with almost nothing? The Martian Mindset adopts a radically new perspective on production on Mars. Instead of adapting Earth technology, we redesign and invent everything from the constraint that we find on Mars. It is structured around 4 key scarcity dimensions that you can find here. So natural resources, human workforce, electric power, and information and communication. Our research focuses on 3 major goals. The first one is the sourcing. So it's an entire research area, and we aim to produce valuable materials and chemicals from low quality ores that you can find on Mars. This includes low energy electrochemical cells, also photoelectrocatalysis, but also microbial synthesis using atmospherical gases and regolith to produce then compound and bioplastic, which is, as you can guess, very interesting for Mars. The second research area is the processing. So once we have sourcing from the materials, how do we have low energy process chains to actually produce materials? Today's production on Earth, the system relies on pure materials and abundant energy. On Mars, it will be the opposite. You will have impure materials and very limited energy. So we develop flexible process that adapts to, different quality of the resources that you will have on Mars. That will be capable of handling if there is impurities or different things that what was planned in the beginning. And the third research area is the operating area. So here we study how to operate an adaptive production facility with human and robot cooperation together, despite uncertainty, a lack of communication, of information. This includes automated monitoring, but also information exchange and study about how you trust an intelligent system or not. I mean, if it said something, if the human said something else, what should you do? Because both are trained, but... So the 3 research areas together will work to, under one goal. It will be to create materials from resources on Mars. And so this is a project that will start, and now you may wonder, okay, there will be a lot of fundamental research in a lot of different fields, but okay, is it actually feasible? That's a good question, because this is very important, proof of concept. To answer this, we are building demonstration processes. One example is the production of the Mars lab, so a new facility that will be built in ZARM, again the institute where I'm working, and it will serve as the production of a rover wheel through process chains only alimented by resources on Mars. This Mars lab is co-funded by the Bremen Senate and also co-funded by the European Union. The construction will start next year and is planned to finish around 2028, with some compartment already being available next year. The user number one will be the cluster of excellence, so the big project I'm talking about, but it will also be open to external users. We'll move to a visual overview, which will be easier. So the Mars Lab, this new facility, will be a controlled environment under Martian conditions. So here we will be able to simulate Martian atmospherical conditions, pressure, temperature, but also operational constraint. And if you remember the member facility that I presented just before, it will, in this scenario, serve as an entire control room with screen and camera and things to control the robots. The production hall in itself will be a bit more than 90 meters square, and it will be composed of an inorganic area, an organic and biological area, two vacuum chambers that will be under Marsh pressure, so 6 millibars. And one of the two vacuum chambers will be filled with regolith to test the resistance of some materials when they are long-term processing materials with regolith condition, because you know regolith, it's a lot of powder and there will be probably powder everywhere when you try to produce materials on Mars. So it's very important to test how robust they are facing dust. And of course the control room, so the member, and also an airlock hub to go through Earth condition to Martian condition. Robots will be working inside, but also times to times human, and they will have to wear a breathing apparatus and also kind of a spacesuit. So I'm quite excited to see this. The entire facility, as I said, will be ready in 2 to 3 years. And by building this, we are creating quite of a unique environment for testing technology and process chains under Martian conditions. Okay, now I've talked a lot about the project, and I would like to talk a bit more about the ZARM, because this is where most of the researchers and facility are right now. Okay, so you have a little video. So maybe some of you already know the Institute. It's a major center for space research in Germany. It's also an ESA official external laboratory, and the biggest facility there is the drop tower that allow experiment in microgravity for almost 5 seconds. And you can double the time if you use the catapult system. Here they conduct research from physics to fluid dynamics to biotechnology. I would like to mention that the Institute of Bremen of using it, but it's also open to the public. So if you are part of a research group or industry and you would like to test your project or whatever under microgravity condition, it can be a very good option, because you just arrive the morning, you take the capsule, we help you putting your experiment inside, and then we'll let it drop, and then you come back home with your data. This is particularly interesting if you're part of a research group that is testing quite dangerous old that could not be tested, for example, on the ISS if you work with fire or potentially explosive compound. But it also hosts the Laboratory of Applied Space Microbiology, so where I'm directly working and doing my thesis. Here we develop life support system for Mars. We try to understand how microorganisms behave under Martian conditions, and we contribute with the biological expertise that is needed for the Human on Mars initiative and the Martian mindset. More specifically, if we take this picture, we work with cyanobacteria, and we use them as a link between Martian resources, so the regolith, the atmosphere, the water, the energy from the sunlight, and then the growth. And then we can use them as first fertilizer for greenhouses behind, but they also produce oxygen, which is really interesting. And in the aim of the Martian mindset, the cluster of excellence, we have already demonstrated, and a research team is already working on the fact that we can use this mix between cyanobacteria and regolith to actually 3D print materials, which is very interesting. For example, we have designed and built a photobioreactor, a very special one. It's called Atmos because it allows the cultivation of the cyanobacteria under low pressure, but also under modified atmosphere. For example, we have demonstrated that under 1000 millibars, so Earth-like pressure, and under 80 millibars, so very low, there is no significant changement in the growth of cyanobacteria. We are also working on designing and prototyping photobioreactor that will have the constraint of Mars, so for example the regolith, because the cyano will need the regolith to grow, but the cyano also needs light, and if you put a powder in the water, then you have the clouding effect, and if you have clouding, you have less light and you have less efficiency. So it's very important to study all of those constraints. For example, we have students working on sintering the regolith in little pellets instead of using directly the powder. We have also research about a closer look on the interaction between cyanobacteria and regolith, so what is happening at a cellular and molecular level, how they can actually bioleach the regolith, like eating all of the nutrients. And we also have adaptive laboratory evolution because, as it was mentioned before, there is perchlorate on Mars, which is okay for some bacteria, but not for cyanobacteria. This is very toxic. So we need to understand how they can resist this. And so through evolution, we were able to create a resistance strain against perchlorate. And now this is currently under analysis to understand how they can actually resist perchlorate, because if you know, you can improve. So I'm almost done. After this presentation, what I would like you to remember is that if someone asks you, oh, in Bremen, how do they contribute to the human exploration of Mars in the Uni Bremen, I really like this video because it's like, you know, putting a little rock on a little rock, and all together we managed to create something. So if someone asks you this question, we never know, you can answer, oh, they had this really great Human on Mars initiative that was the starting point, creating and laying the foundation of knowledge for the Martian mindset, this large-scale main collaborative project. All of the infrastructure and experimental platform and a lot of facilities are in the ZARM Institute. And the last, so Laboratory of Applied Space Microbiology, is in charge of the microbial process for resource production. And this is how we go from concept to real solution. And thank you, I hope it was not too long, and if you have any questions.
Okay, let's yes, one or two questions maximum, then discussion panel. Please.
Then we can go to the panel again.
Thank you for this great presentation. What will you be building as an object in your facility?
A rover wheel. Yeah, I maybe did not say it was on the slide. We will produce rover wheels from only resources on Mars through process chain in the Mars facility lab, and until we have these rover wheels, in case of a rover lose a wheel on Mars, will be quite interesting.
For a bicycle also?
If you want, why not?